Dear students, this is a session of compiler design subject. In this we are going to see bottom-up parsing technique. Here we are going to cover these topics: shift reduce parsing, operator precedence parsing, LR parsing, then constructing SLR parsing tables, constructing canonical LR parsing tables, and constructing LALR parsing tables. Let us see the classification of parsers. Parsers are broadly divided into top-down parsers and bottom-up parsers. Top-down parsers, two types with full backtracking, which uses brute force method, and another type is without backtracking. We have two types of it, that is recursive descent parsers and non-recursive descent parsers. They are otherwise called LL1, which we have already seen in the predictive parsing techniques. Bottom-up parsers are of two types. One is operator precedence parsers, the other one LR parsers. LR parsers, we have four types of it, that is LR0, second one simple LR, or it is referred as SLR1, canonical LR or CLR1 or LR1, then comes LALR1. So these are the parsing techniques that we will be seeing in detail in this particular session. Operator precedence parser we will see in the end. So bottom-up parsing is a technique which attempts to traverse a parse tree bottom-up. So if you remember the post-order traversal technique that you have learned in earlier semesters, the parse tree is constructed from bottom of the tree upwards. So at each step you will be reducing a sequence of tokens, and finally you reach the start symbol. At each reduction step, the right hand side of a production will be replaced with the left hand side of the left hand side non-terminal. Single non-terminal will be there for each of those productions. So at each reduction step you will be replacing the right hand side with the left hand side. So basically it corresponds to each of these reductions which will correspond to the reverse of a rightmost derivation. You already know what is a rightmost derivation. You will be replacing the rightmost non-terminal with the corresponding body of that production. So in bottom-up parsing, it is implemented by reducing a particular right hand side of a particular production with the left hand side non-terminal. Let us see that using this example. You have this expression grammar that we have been seeing in top-down parsing also. Here one thing to be noted is you don't need to have this additional tasks of eliminating left recursion, left factoring. All those steps are not required. You can directly start with the bottom-up parsing. So it is pretty easier compared to top-down parsing, and powerful also. Okay, let us see the bottom-up parser of this particular id star id, that is the string that which is given to us, and we have three tokens id star id. Okay, first step is take this id star id. Now you have to identify a particular substring from this particular string which forms the right hand side of a production in the grammar. So you have, let us see, you start from the left portion of this string. So you have id here. id forms the right hand side of a particular production. F gives id, so id can be replaced using f. That is which is happening here. So id is replaced with f. Now you have to now identify another substring. Now actually id star id has become f star id. So from f star id we need to identify a substring which forms the right hand side of a particular production in the grammar. So here you are identifying f as the substring. From this f star id, f is the substring that could be replaced with the left hand side of t gives f production. Okay, so f will be replaced using t. Now you will get a doubt that why this id, since you have two candidates here, f and id, which forms the right hand side of productions here. So one is t gives f and the other is f gives id. So id also could have replaced using f, but that is the essence of this bottom-up parse, where you will not do that according to the rules being set for this bottom-up pass. So here what happens is f is reduced to t. Using this production, t gives f. So f becomes t, and which makes it t star id. Now in the next step, again this id will be replaced using f, which makes it t star f. Now we have to see this string, and a substring of it has to form the right hand side. Now if you see the whole of the string forms the right hand side of a production, which is t gives t star f. So t star f could be replaced using t, which happens in the next step. See here. So this tree gets converted in the reverse manner, and now this t, now you have only t as the string, and the t forms the right hand side of a particular production. E gives t, which makes the reduction possible to the start symbol e. So e is the root of this tree, which is the start symbol here, and this is the whole tree, which makes the bottom up pass complete. And it also means id star id is a valid string for this particular grammar. So to go about bottom up passing, you need to know what is a handle. You already know what is a right sentential form. So a right sentential form, if you take this example here, that is s, that is a start symbol, derives alpha in multiple steps using a rightmost derivation. So in this case, alpha is a right sentential form. So whenever you have a rightmost derivation, at each step you will get a right sentential form. Handle is identified associated with a right sentential form. So it is a substring beta that matches the right hand side of a production. A gives beta. This substring beta means the substring is of a right sentential form. So this handle has to be has to be a handle only if it is a substring beta that matches the right hand side of a production. A gives beta. Okay, so this beta has to be a substring of a right sentential form, and it has to match the right hand side of a production. A gives beta. Again, the next condition for the handle is the beta. When it is reduced to a, it has to be a step along the reverse of some rightmost derivation. Okay, so for a handle to be identified as a handle from a right sentential form, it is a substring beta that matches the right hand side of a production. A gives beta, and reducing beta to a has to be a step along the reverse of a rightmost derivation. So you find a substring which matches the right hand side of a production. A gives beta, and it does not satisfy the second condition. That doesn't mean that means it cannot be identified as a handle. So for a handle to be a substring taken from a particular right sentential form, it has to follow both these. It has to satisfy both these conditions. Okay, let us see this scenario here. S derives gamma a w in multiple steps in a rightmost derivation, and in the subsequent step, this gamma a w becomes gamma beta w. Why? Because a is replaced using beta in this derivation. So derivation means it's a forward activity. So a gets replaced with beta. Since we have a production a gives beta in the grammar, a gives replaced with beta. So since it is a rightmost derivation, you can get something else also from this, where a is getting replaced using beta. That means a is the rightmost non-terminal in this particular sequence, which means w will have only terminals in it. So a is the last or rightmost non-terminal available in this particular sequence of symbols, or this can be called as a right sentential form, since we are following a rightmost derivation. So w is a sequence of tokens, and the substring beta of gamma beta w and the production a gives beta make this beta as the handle of this particular sentential form. Actually, from gamma beta w in the bottom up passing technique, you will be traversing from gamma beta w to gamma aw. So since for beta could be identified as a handle, this condition has to be there. Okay. Now let us see this handle pruning technique. What do you mean by a handle pruning? That we will see. Let us see this expression grammar, and we have the rightmost derivation for a particular string, that is id plus id star id. So e, you start with start symbol e and replace with the right hand side of productions in this grammar. E gives e plus t, since it is a rightmost derivation, t will be replaced using t star f, and this f will be replaced with id, and this in the next step t will be replaced. T will be in this step, t is the rightmost non-terminal, which is replaced using f, and finally step by step you reaches this id plus id star id, which makes this sentence valid for this particular grammar. Okay, now let us see this reduction process of id plus id star id to start symbol e. How this id plus id star id reaches, or after so many reduction steps, how it reaches e, we will see here. So each of this step you will have a sentential form. So e plus t is a sentential form, e plus t star f is a sentential form. Like that, finally you reach this sequence of terminals. So let us start with id plus id star id. There you have to identify a substring as the handle, so that that substring has to be on the right hand side of a particular production, and also it has to qualify that when it gets replaced using the left hand side, it has to form the reverse, it has to form a reduction step just previous reduction step in the rightmost derivation. Okay, so id gets replaced using f. So when you see here this red marked underlined red in red, whatever is indicated is are those handles that we are identifying from this particular sentential forms. So id plus id star id is a sentential form where you identified id as the handle, and that gets replaced using f. The production that you use for that is this, and f plus id star id, from that particular sentential form you identify f as the handle, and f will be reduced to t using this production, t gives f. So now you get t plus id star id, t will be the handle there, and e gives t. Using this production you reduce it to e. Now from e plus id star id you identify this particular string, substring of this string, e plus id star id. Id is a substring that could be reduced further, so that it makes the reverse of this particular rightmost derivation. Okay, so id is the handle here, it gets replaced using f. Now again, from this particular sentential form, f is the handle, so you use t gives f. Now e plus t star id, in this string id is the handle, gets replaced using f. Now e plus t star f, from this particular string t star f is the substring which satisfies a handle, so t star f is the handle, it gets replaced reduced to t using this particular production, now which makes it e plus t. So e plus t is the handle here, and which get replaced to e, so that you reach the start symbol. So handle could be identified, or how handles are identified, like it is based on the rules that we have just discussed. It has to form, it has to be a substring of the sentential form, and it has to be a right hand side of a particular production, and when it gets replaced, it goes to the next step, it has to be a particular reduction step has to be going in the reverse order of a particular rightmost derivation. So when you see here, when you see these steps here on your left, this is the reverse of it actually. So that is how this id plus id star id is reduced to e. So this is identifying these handles and finally reaching the start symbol is called handle pruning.